So my derivative is going to equal 1 over, this is cosine. Here in general is what the cosine of something is equal to. The square root of 1 minus sine squared y, or rewriting this is like this. 1 minus the sine of y squared. And in this problem, I know what the sine of y was equal to. It was equal to x. So then I can rewrite the derivative as 1 over the square root of 1 minus x squared. You can do this like by hand, switch and you get in this form, but then you have to convert it in terms of x, the derivative in terms of x. You would have to use one of your identities. Sine squared plus cosine squared equals 1. And then you can solve for cosine y equals the square root of 1 minus sine y squared, and then sine y, in this case, equals x. So then you can just plug it back in. So now the derivative is in terms of your input x. Okay? And that is the general equation. For any inverse sine function or arc sine function, in terms of whatever's inside this parentheses, the derivative, dy dx, is equal to 1 over the square root of 1 minus u squared times the derivative of whatever's inside that parentheses. Chain rule it. Okay? So, for example, if you have something like y equals the inverse sine of 3x squared, you can either go through this whole process, or, from your flashcards, you say the derivative, d dx, is equal to what? One over the square root of 1 minus whatever's inside that parentheses squared, the whole thing squared, times the derivative of what's inside that parentheses. So then if I simplified this, y prime equals 6x, if I multiply across, over the square root of 1 minus, now everything is squared in here and there's no plus sign, so I can just square everything. Question? The derivative of the inverse sine is this. It's not like derivative of sine is cosine, derivative of cosine is negative sine. This is the equation for the derivative of inverse sine. This. There is no more sine or anything. Other questions? Okay. What's the derivative of that in your groups? Don't switch to the x and y's. You know what I'm saying? You don't need to anymore. You know the rule. You know what the derivative of inverse sine is. So you just got to follow the rule. This is the memorizing part of it. Overall, what type of problem is this? So treat it like a product rule. Y prime equals the derivative of the first times the second plus first times the derivative of the second. Now, in that box, you go, oh, shoot, I have to take the derivative of inverse sine. Oh, I know what that is. 1 over the square root of 1 minus x squared times the derivative of x, which is, and you're done. Why what? Is yours with Amina's questions like, how did I just take the derivative of inverse sine so quickly? Product rule, derivative of the first times the second plus the first times this box is the derivative of the second. This is the derivative. U is whatever is inside there.
So that would be 1.
Times 1, yeah.
Okay, I got you.
So here's the deal, you guys. Again, after 3.9, we have one other section after this, which is just exponentials and logs. You will physically know how to take the derivative of anything I could ever throw at you ever. You know what I'm saying? These are some rules that you need to learn. So ever throw something like, hey, what's the root of x squared sine inverse x? What does that graph look like? I don't know. I have no idea. You know what I'm saying? You can actually graph this one actually, because this is all in terms of one variable. You can graph this if you want to see what it looks like, since it's just in terms of x.
Can you simplify?
I mean, you can. So then, this would just be x squared over the square root of 1 minus x squared. But then you can't combine anything here and here, so you're done. Okay? Does that make sense, you guys? So, in the notes, there's a relationship between the inverse sine and the inverse cosine. It says that the inverse cosine of something is equal to pi over 2 minus the inverse sine. Okay, that's great. Why that's helpful to us is if I wanted to graph or find a value of the inverse cosine, I would just have to take the derivative of this. And what's the derivative of this? What's the derivative of pi over 2? 0 minus, what's the derivative of the inverse sine? That. So if you understand the inverse of the derivative of the inverse sine, the derivative of the inverse cosine is just the negative. And you're done. It's just like, what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. The negative. And all the co's are still going to be negative. Anything without a co is going to stay positive. Anything with the co is going to be negative. The derivative of the arc cosine, or inverse cosine, is negative 1 over the square root of 1 minus u squared times the derivative of u. The derivative of inverse sine is 1 over the square root of 1 minus u squared times the derivative of u. Okay, does that make sense?